This is lesson 2.5 out of the Rates, Ratios, and Statistics book. In my class, this lesson is on page 112, and lesson 2.5 is titled Comparing Rates. So there isn't anything really new in this lesson. It's all about making equivalent rates, and then you're just going to compare which one is less than or greater than in some form or another. So it should go pretty easy for you. But as always, we have our warm-up first. And the warm-up is find each unit rate. And the first one is 125 miles per 50 minutes is equal to what? Number 2 is $4.50 per 9 lollipops is equal to what? Unit rate. All right, and then the next one is, let's see, how am I going to do this? Oh yeah, okay. Complete each equivalent rate. And number 3, we have 20 miles per 1 gallon is equal to how many miles per 4 gallons? And number 4 is 10 meters per 8 seconds is equal to how many meters per 40 seconds? All right, that's your warm-up problems. Okay, so I can statement for this lesson. I can compare rates using equivalent rates, equivalent, and unit rates. Just barely get it in there. I can compare rates using the equivalent and unit rates. So we did this in lesson 2.4. Learned how to make equivalent rates and how to make unit rates, and now we're comparing them. So that's the extra piece we're adding into this. Okay, so I have one piece of notes here, and I want you to cut the notes off right underneath the text so that we've got as much room here to make notes as we can. We'll put this up in the usual spot there, and I want as much room underneath it. So this is a notes that's like the usual this big. So just cut this, hold still. Cut this part that's just blank off. Sometimes I have you leave that on there because I'm going to write some notes in there. This isn't one of those times. Just go ahead and give it a cut right under the text. So then you have a tiny little piece of paper that looks like this. Comparing rates. Our steps for comparing rates. So to compare rates, first step is to Write each rate as a unit rate with the same units in the numerator and the denominator. That's what we've been doing. You already know how to do this. And then the second step is to compare the values of the numerators of the unit rates to determine which rate is larger or smaller. Okay? Once you have the denominators as a 1, no matter what the unit is, then you can compare the numerators to find out which is larger, which is smaller. All right, so the first example of that we will do is, which is the better deal? All right, and I'm going to take my green highlighter. This is example 1, which is the better deal. All right, and we are talking about $3.20 for a 16-ounce box of cereal. Got it. For a 16-ounce box of cereal, or $2.52 for a 12-ounce box of cereal. Okay, we're going to figure out which one is the better deal. Well, I have to find unit rates first in order to compare. I can't compare these because my denominators are not the same. Okay, I can't compare 16 ounces to 12 ounces. I have to have a unit rate where they are both 1 ounce. So that's where I'm going to first have to put this into a unit rate. So step 1 is to put it into a unit rate, which I'm doing right now. So now I have 1 ounce of cereal. And also here, 1 ounce of cereal. All right. Now, what do I have to do to get 16? Oh wait, I'm going to take my blue here and put a 1. This was step 1, setting up these unit rates. Right? So now, what do I have to do to get 16 to a 1? Well, I have to divide by 16. And what I do to the bottom, I have to do to the top. So now I have to divide $3.20 by 16, which equals 20 cents. So 0.20. All right? Now I got to figure that out for the 20-ounce box. Well, I need to divide that by 12. I'm sorry, not 20 ounce, 12 ounce. I need to divide that by 12 to get to 1. What I do to the bottom, I have to do to the top. And $2.52 divided by 12 is 21 cents. All right, so which one is the better deal? Well, obviously, this larger box of cereal for a cent per ounce less is the better deal. So here's where I would write, we need a sentence here, the 16-ounce box costs less. It's the better deal. All right? It is the better deal. All right, I'm going to take a line on my light green and go all the way down like this and all the way under here. Separate our different examples. All right? Okay, so that's our first example of comparing rates. And that was unit rates in that case. All right, our second one. Which bag of apples costs less? Right? So the first one is $4 for an 8-pound bag. For 8 pounds. All right. And I need to know, got to get it to a unit rate, how much that is for 1 pound. All right. And the second one is $1.80 for 3 pounds of apples. And again, I'm going to have to figure out what that is as 1 pound. It's unit rate. So step 1 is setting up the unit rates. I did that, right? Step 2 is figuring out the numerators so that I can compare them. I have to divide this 3 by 3 to get to 1. And what I do to the bottom, of course, I have to do the top. And 3 goes into $1.80 to become 60 cents. So 3 goes into 18 6 times. All right. And this one, I have to divide by 8. What I do to the bottom, I have to do to the top. And 4 is divided by 8 to become 50 cents. So which one costs less? The 8-pound bag. All right. So the 8-pound bag of apples cost less. All right. Oops, get my sentence up there. That's how we do that one. Okay, one last example, and we'll be done with our notes. We'll do that one over here. All right, so this one is, which vehicle gets better gas mileage? Okay, which vehicle gets better gas mileage? Oh, I didn't highlight this over here, did I? Wanted to. All right, which vehicle get better gas mileage? All right, so we have a car and we have a truck. All right, and the car is getting 150 miles per 10 gallons. All right, and we're going to have to find out what that is per 1 gallon. And the truck is getting 96 miles per 6 gallons. And again, we'll have to find out, well, how much is that per gallon? All right, so that was our step 1. We set up the unit rates. Now we have to do the multipliers to figure out what the numerators are so we can compare. All right, so on the first one, 10 divided by 10 gives us 1. And what we do to the bottom, we have to do to the top. So 10 goes into 150, 15 times. So we've got 15 miles. So the car is getting 15 miles to the gallon. Now on this one, we have to divide by 6. And so what we do to the bottom, we have to do to the top. And 6 goes into 96 16 times. Okay. So the truck is getting 16 miles to the gallon. So this is a tricky part. I want you to think about this. Often we get used to looking for the smaller number, and which one gets the better gas mileage? You might think the car because you're used to looking at the smaller number. But let's think about this carefully. If I want the better gas mileage is the one that's going to go farther on a gallon of gas. So which vehicle went farther on the gallon of gas? Well, the truck did. Not by much, but it did. So the truck gets better mileage, which is not very usual, I would have to say. The truck gets better mileage because I don't know what kind of car this is. I don't know what's happening with this car that it only gets 15 miles to the gallon, because that is really like really, really, really bad. That's not terribly uncommon for like a big pickup or SUV or something, but not for a car. So I don't know what they're calling a car in this example. That would be bad. Anyway, in this example, the truck is getting the better mileage. All right, so there's your notes there. Now, let's take a look at some practice problems. Okay, here's your practice problems for lesson 2.5. There's only 3 of them, and they're pretty much just like what you did in the notes. So the first one says, boy, we're really getting glare, huh? First one says, is it a better deal to buy a 20-ounce box of cereal or a 16-ounce box of cereal for $3? All right, so you're going to have to set that up and figure out what's the better deal. That doesn't look right. I'm not sure that problem's written right. I have to go back and look. 20 ounce. 16 ounces, $3. Yeah, and the 20 ounce, I'm sorry, I made a mistake when I wrote this out. The 20 ounce box is $3.50. And the 16 ounce box is $3, right? Yeah, sorry, I didn't write that out right. All right. Number 2. Get that out of the glare. It's worse there, huh? All right. Number 2. Which vehicle gets better gas mileage? A truck that travels 448 miles on 14 gallons of gas, or a car that travels 408 miles on 12 gallons? And then the last problem. A 10-pound bag of potatoes costs $40. A 6-pound bag costs $2.70. Which is the best deal? All right, so let's work these out. The first one. So we've got $3.50 for 20 ounces of cereal. And that, in the unit rate for 1 ounce, is going to be, I divide that by 20, and I divide this by 20, right? And I get, and you won't get an even number. When you do the long division, it'll be 0.175. But that's okay. We're not trying to find its cost. We're trying to find numbers that we can compare. So then it's $3 for 16 ounce of cereal. And so we have to turn that into a unit rate. 1 ounce, that means we divide by 16, divide by 16 top and bottom, and 16 goes into $3, 0.1875. So you would round that to the hundredths place when we're talking about money. But we want to be able to see which is the better deal. So obviously, which one is the better deal? The 20-ounce box is your better deal. You're paying less per ounce when you buy more. That's often the case. Okay, number 2. Which vehicle gets the better gas mileage? We've got a truck and we've got a car, just like in our notes, all right? So the truck, it is getting 448 miles per 14 gallons. Well, let's figure out how much that is per gallon. So for 1 gallon, I have to divide that by 14, top and bottom. And 448 divided by 14 is 32 miles. So the truck is getting 32 miles per gallon. That's pretty good for a truck. All right, now the car is getting 408 miles per 12 gallons. So how much is that per gallon? Well, 1 gallon, I have to divide that by 12, top and bottom. 408 divided by 12 is 34. So the car is getting 34 miles per gallon. Now, let's remember what we want is for it to go as far as possible on a gallon of gas. Which one's going farther? The car is, right? So the car is getting the better gas mileage. All right, last problem. A 10-pound bag of potatoes costs $4 and a 6-pound bag costs $2.70. Which is the better deal? All right, so let's deal with the 10-pound bag first. It's $4 for 10 pounds. How much is that per 1 pound? All right, well, we divide that by 10, top and bottom. All right, and 4 divided by 10, we just move the decimal point. We've got 0.40, so that's 40 cents. Okay, that's for the 10-pound bag. Now let's figure out what it is for the, am I in there? Yeah, okay, for the 6 pounds. For the 6-pound bag, and it costs $2.70. So for 1 pound, we've got to divide that by 6, top and bottom, and $2.70 divided by 6 is 45 cents. So which is the best deal? Well, I'm going to pay less per ounce for the 10-pound bag than I would the 6-pound bag. So the better deal is the 10-pound bag. All right, so that is your practice problems. Let's take a look at your worksheet for lesson 2.5. Problems 1 through 4 are just very simple. Turn them into unit rates and then compare which of the two is smaller. Remember, they're asking which is smaller, okay? So sometimes you don't have to turn it into a unit rate. It already is, so that makes your problem quicker. You just turn the other one into a unit rate and then do your comparisons. All right, so problems 5 through 6 are word problems, just like we did in our notes and in our practice problems. Nothing too difficult about them. Okay, and then this last problem down here, it's talking about use equivalent rates to determine the cost for 30 pounds of Hermiston watermelons from a local farm if the farm charges, and there's 2 different problems, okay? So equivalent rates. So you're going to first set it up with the rate here. So in this case, $1.50 over 1 pound equals how much for 30 pounds? Right? $5 per 3 pounds, that's your rate, equals how many for 30 pounds? And you're using equivalent rates. All right? And that's it. Yeah, that's it for your worksheet. Okay, so let's take a look at your exit ticket for lesson 2.5. Just for practice, a little extra assurance that you've got this down. Okay, so that's lesson 2.5 out of the Rates, Ratios, and Statistics book. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.